All right, so day 6 homework. The first one, you're solving using completing the square. So we need to make sure the leading coefficient is 1, which it is. So now let's move the constant to the other side. So we have x squared plus 6x, and then this is going to be added over, so plus 11. To complete the square, take the b term, cut it in half, and square it. So that's going to give us 9. Add 9 to the left side, and then balance it by adding it to the right side. From here, now you can factor this. So when you factor, this factors into x plus 3 times x plus 3, or we can write it as x plus 3 squared. Over here, this will just give you 20. All right, here's where it gets different. Take the square root of both sides. Square root of x plus 3 squared is just x plus 3. Here, you have to remember that you're going to be left with a plus or minus whatever you have over here. So this radical 20, I can break down into radical 4, radical 5, which is going to give me plus or minus 2 radical 5. And then my last little step, get x all by itself. So I'm going to subtract the 3 on over, and I'm going to write my answer as negative 3 and then plus or minus that 2 radical 5. You could also put the minus 3 at the end of it. And then if you'd like to see it as 2 separate answers, then it would be negative 3 minus 2 radical 5, and then negative 3 plus 2 radical 5. Okay. So just double checking the directions. State whether the roots are real or imaginary. All right, so last part. Those are real numbers. There's no i's in there. So those are real roots. All right, let's do the next one. So here, let's set that up correctly. Same thing. This is a 1. Move the constant to the other side. So I'm going to get x squared plus 8x, and then I'm going to subtract that over, so I get negative 12. All right, b term, cut it in half, square it. So 8 over 2 is 4, squared is 16. So add 16 here, add 16 over here. Factor this guy. This will factor into x plus 4 times x plus 4, or I can write it as x plus 4 squared. Over here, this just gives me 4, and then take the square root. So I take the square root, I'm going to get x plus 4 by itself. Here, I'm going to get plus or minus, and then it's just plain old 2. If it comes out nice and pretty like that, then you just have to remember, I'm trying to focus it a little better for you. You have to remember you're going to split this up. So x plus 4 can equal negative 2. X plus 4 can equal positive 2. So, because I should always get 2 solutions, right? So subtract 4 on over. I get x equals negative 6. Subtract 4 from this, I get x equals negative 2. And those are both real roots. There you go. All right. Next one. Number 3. It started with things on both sides. You can move it over to get it equal to 0 first, but then you're going to immediately move that constant to the other side. So I'm just going to go right to moving the 22 on over so that the x terms are on one side. And then if we use 7 minus 22, we'll get negative 15 on the other side. All right, this one's going to be a little bit messier. 13 divided by 2 squared. Well, 13 squared is 169. 2 squared is 4. So I'm going to add that to both sides. So add 169 over 4 here and 169 over 4 there. All right. Remember, when this looks a little weird, what's going to go into the factored part is always whatever the b over 2 is. So plus 13 over 2 and x plus 13 over 2. Or I can write it like that, squared. Right, on this side, you can get a common denominator and do it yourself, Or I can simply just say, all right, let's go negative 15 and then add to it 169 over 4. I am going to math bracket so that that is 109 over 4. And you'll see in a moment why I like to leave it that way. Okay, when we go to take the square root, left side is just going to be x plus 13 halves. On the right side, plus or minus, you can break this back up. You can do the square root of the numerator and then over the square root of the denominator. When I do that, that's going to give me x plus 13 halves equals plus or minus radical 109 and then over plain old 2. So that when I go to finish this, I'm going to subtract the 13 halves to the other side. You could tack it on to the end. I kind of like to put it up front. So it'll be negative 13 halves plus or minus 109 over 2, which when we do quadratic formula, which is going to be tomorrow's stuff, you could write this if you want as one single fraction, since you have a common denominator. That would look like this. Your other option, of course, one answer would be negative 13 minus radical 109 over 2. The other answer is negative 13 plus radical 109 over 2. There's nothing wrong with keeping them together as long as you can't like simplify it further. And that's as far as that guy would go. All right, let's do one more like this, and then we'll do the one on the back. So for this one here, x is on one side, constant on the other. I'm going to add the 20x over to the left. In the same step, I'm going to add the 7 on over to the right. So this is going to give me 4x squared plus 20x and then equals 7. All right, this one has a leading coefficient. So I need it to be a 1. Divide everything by 4. This is going to give me x squared plus 5x, and then I'm left with a 7/4 over here. All right, now you can do the completing the square step. So take 5, cut it in half, square it. That's going to give me 25/4, which is what I'm going to add here, and it's what I'm going to add over here. All right, on this side, this will now factor into x plus 5 halves times x plus 5 halves, which I'm going to go right to just writing as that squared. On this side, 7/4 plus 25/4 will give me 32/4, which really just gives me plain old 8. All right, my next step, I'm going to go in and take the square root. So let me rewrite that to make sure that we're good. Take the square root of both sides. I'm going to get x plus 5 halves. This, I'm going to get plus or minus and then break it apart. Radical 4, radical 2, which really means I get x plus 5 halves equaling plus or minus 2 radical 2. And then you can get the x alone by sliding that 5 halves to the other side by subtracting it. All right, final answer, negative 5 halves plus or minus 2 radical 2. If you'd like to see what it would look like separate, sorry, I was a little off the page there. You can write it as 2 separate solutions. That would be negative 5 halves minus 2 radical 2, and then negative 5 halves plus 2 radical 2. Just realized both of these are real roots. For them to be imaginary, we would have to have a negative underneath that radical, and then an I would pop on out there. So keep your eyes open for 5 and 6. Maybe you're going to have an imaginary answer there. Otherwise, the last question, number 7, this one here, when it asks for you to get it into vertex form, first thing you got to do is be able to keep the y and then divide everything by 2. So if we divide all of this by 2, this is going to give me y over 2 equals x squared plus 6x plus 5. And then you can move over the 5. So minus 5, leave a little space. Right, b term, chop it in half, square it. That's going to give me a plus 9 here. So plus 9 over there. Make sure you're adding it to both sides. And then from there, this will give us y over 2 plus 4. This will factor into x plus 3 quantity squared. Start moving things back around. We get y over 2, x plus 3 squared, and you would subtract this 4 back over, and then I can double everything. I heard some questions about like, when do you do the doubling? You could do it back here, or I can move it and then double. Doesn't matter. All right. That's my equation in vertex form. So then the actual vertex, so part A, would be -3, -8. All right, that's the first part. Second part, what's your x-intercepts? So you can set y equal to 0. You can do that in the original equation, or you could do it in our vertex form. So to kind of look at how it would work with this, let's put a 0 in there. X plus 3 squared minus 8. From here, add the 8 to the other side. Divide everything by 2. This would give me 4 equaling x plus 3 squared. And then we would go and take the square root of both sides. So I get x plus 3 equals plus or minus 2. Those are going to be actual nice numbers. So split it on up. If -2 equals x plus 3, and if +2 equals x plus 3, your two solutions would be -5 and then -1. So as actual coordinates, it'd be -5, 0, and -1, 0. All right. To do part C, y-intercept, set x equal to 0. So take the original or the vertex form, totally up to you. Throw in a 0 there, throw in a 0 there. What you're going to see is you're left with just plain old 10. So the coordinates there would be the point 0, 10. I'm going to box all that stuff in. Oops, sorry, I was a little off the page there. -5, 0, -1, 0. Axis of symmetry. That is always just x equals, and then whatever the x coordinate of the vertex is. So since the vertex back here was -3, -8, it's x equals -3. The sketch, right? You have graph paper. I unfortunately do not. So to the best of my ability, if I'm looking at this, let's see, cross it up here, let's say at 10, you've got it crossing over here at -1 and -5. Vertex is at -3, -8, so like way down here. And so then it should look a little something like that. All right, last one, domain and range. Domain, covering everything, -infinity to infinity. Your range, think bottom to top. The lowest point it goes to is that -8 right there. So -8 on up to infinity. All right, I hope the video helps. Hopefully I'll see you guys tomorrow.